using halo acids. Okay, so now the fourth one is, this is the method of preparation by using sodium bromide, NaBr, right? So using sodium bromide in the presence of sulfuric acid, we can also prepare your haloalkane. Okay, so this is again a preparation by using alcohol, but in this case we use the reagent sodium bromide along with your H2SO4, sulfuric acid. Okay, so basically when alcohols are treated with sodium bromide in the presence of sulfuric acid, right? So then HBr is formed. HBr is formed, which reacts with alcohol to give alkyl halide, right? So from this combination, NaBr and H2SO4, this basically form HBr. And this HBr, it just reacts with, right? So from here, it will be H plus and Br minus, right? So this Br, it just, this OH will be replaced by this bromine group, and you will get the alkyl halide over here. You will get alkyl bromide in this case, along with the byproduct sodium hydrogen phosphate. Okay, so NaHSO4. Okay, so again I'm repeating. So again, this basically we just learned that in the formation of haloalkane, this uh, alcohol group is basically replaced by a halogen group to form the alkyl halide, corresponding alkyl halide, right? So in this case, when the alcohols are being treated with sodium bromide with H2SO4, so this NaBr, sodium bromide and H2SO4, they just react with themselves to form HBr, right? They produce HBr, and this HBr, it just reacts with ROH, right? And this Br, it just replaces this OH group over here, and it will give you the product alkyl bromide. Alkyl bromide along with the byproduct NHSO4. Got it? Yes
Yes,
or no?
ma'am.
Okay. And yeah, just remember, this above method is cannot be used for the preparation of aryl halide. This is only for the alkyl halide. Okay. Why in aryl halide? So we know that in aryl halide, between the carbon and oxygen bond of phenol, suppose this is your phenol structure, right? So you can see this oxygen, this has a lone pair, right? So basically this has a partial double bond character, right? This phenol has a partial, between this carbon and oxygen, there is a partial double bond character due to the resonating structure, due to the resonance, this oxygen is not free for the protonation, right? So it is very difficult to break this bond due to the resonance. Okay, so that's why this above method cannot be used for the preparation of aryl halide. It is only used for the preparation of alkyl halide. Okay, and see the rate of reaction of this will be benzyl. Benzyl में सबसे fast होता है, right? So in benzyl it will be very fast. Then allyl, then 3-degree alcohol, then secondary alcohol, then primary, then methanol. Okay, so just remember the sequence. Well, okay, so we know that what is benzyl alcohol. Who will tell me what is benzyl alcohol? So the halogen group is attached to sp3 hybridized carbon, right? And this sp3 hybridized carbon is attached to the benzene ring, right? So the rate of reaction in benzyl alcohol or benzyl group is very fast, right? You will see this reaction, it will be very, will proceed in, will proceed very fastly in benzyl type of alcohol. Then allylic, then tertiary, then secondary, then methanol, then sorry, your primary one, then methanol. Okay, so just remember this sequence. Now here's a question. Why sulfuric acid is not used during reaction of alcohol with HI? With HI. Okay, so basically this HI, because we know that sulfuric acid is very strong oxidizing agent, right? This is very a strong oxidizing agent. So it can easily convert this HI to I. right? Because it's an oxidizing agent, a strong oxidizing agent, so it can easily remove this hydrogen and it just convert Hi to I, and which this I which doesn't react with alcohol. Okay, so this Hi has been converted to iodine, which doesn't react with alcohol. So instead of sulfuric acid, we use mild oxidizing agent, which is H3PO4. H3PO4 is very much mild oxidizing agent. So when you just take Hi, right? When you take Hi, so just use the mild oxidizing agent H3PO4 instead of sulfuric acid. Okay, so this H3PO4, this provides Hi, right? And it doesn't convert this Hi to I. And for this, you will proceed the reaction, right? So when you are taking Hi, halo acids, if you take the iodide acid, Hi, so just take ROH, okay? Just alcohol when it treats with Hi along with H3PO4. Now, in this case, you will not take your sulfuric acid, right? Because sulfuric acid is a strong oxidizing agent. It can easily convert this Hi to I, and it doesn't react with this to form Ri. Okay, so that's why you just take H3PO4 because it's a mild oxidizing agent. So it doesn't convert this Hi to I. Okay, and so that you can further convert this, you can further achieve your desired product, desired alcohol, sorry, desired alkyl halide, which is Ri over here. Okay, alkyl iodide. Got it or any question? Concept is clear?
Yes, ma'am.
Okay, so just remember that when you are taking Hi, so don't take H2SO4 along with Hi. Okay, because H2SO4 is a strong oxidizing agent. It can easily convert this Hi to I only. Okay, and I doesn't react with H2 your alcohol, corresponding alcohol to give your corresponding alkyl halide, alkyl iodide in this case. So you will not get the alkyl iodide. Okay, तो अगर आपको alkyl iodide चाहिए product में, so just use this Hi along with H3PO. Okay, now you can write this using sodium bromide in the presence of sulfuric. Written?
May I please hold on?
Okay, just a second. Okay, right. Written? What have you written?
Yes, ma'am.
Now, from simple hydrocarbons, we can also uh, prepare your haloalkene. Okay, from hydrocarbons only, we can prepare your haloalkenes. And in hydrocarbons, from hydrocarbons, we will see many preparations like from free radical halogenation of alkene, like by hydrohalogenation of alkene, etc. Okay, so let's see one by one what are these. And just please just focus here. This is very, very important. This is very, very important. So first is your by hydrohalogenation of alkene. Okay, so in this preparation, basically halogen acid, when treated with alkene, okay, we just take a halogen acid, any halogen acid, when it treated with alkene, so it undergoes addition reaction. Okay, यहाँ पे क्या होता है? Basically, it will undergo electrophilic addition reaction. Okay, so electrophilic addition reaction, and you know what are electrophiles? Monica and Jubita, what are electrophiles? Yeah. You know what are electrophiles? Okay, so see, electro and philes. Electron loving. Electron loving. Right? So philes means, phile means any loving. So electron loving होते हैं basically we can call it as an electron deficient because इनके पास electron की कमी होती है. That's why they love electrons. Okay, so they can accept electron. They are basically electron acceptor. So electrophiles are those species which are electron deficient. Basically cations होते हैं ये. Right? So cations they have the deficiency of electron. Okay, so they are electron accept, electrophiles, electron loving particles or electron loving species. Okay, similarly, nucleophiles. Nucleophiles means they are electron rich and they love nucleus, means the positive ions. Okay, nucleus loving होते हैं, nucleus क्या होता है? They are positive, right? So basically, so electron rich species are known as nucleophile and electron deficient species are known as electrophiles. So just remember that. So this is the type of electrophilic addition type of reaction which yield your haloalkene. Okay, so basically when you take alkene and when you treat it with halogen acid, it will give you your corresponding haloalkene. Okay, let's see the mechanism first. So basically this halogenation of alkene. So basically, just a second. Yeah. I'm explaining it over here. So this method is, this is from alkenes. Yeah. So we will see, just a second. This is from using halogen acid. So from alkene, we can use halogen acid to prepare your haloalkene using halogen acid. Right? Either it can be HCl, your HBr, or HI, yeah, etc. Now there are two conditions. There are two cases you can say. First case, if the alkene is symmetrical, if we have symmetric alkenes, and the second case is of unsymmetric alkene. Unsymmetric alkene. Okay, so just focus it here. Now, if the alkene is symmetric, okay, example, if the alkene is symmetric, suppose it's CH2, CH2, ethene. Okay, so you can see over here, this is a symmetric alkene. Okay, so when you treat the symmetric alkene with HCl, okay, so let's see what you are supposed to do. So if the alkene is symmetrical, okay, so what you have to do is just break the pi bond. Just break this pi bond, okay, and add hydrogen on one carbon and add halogen on the second carbon because it's symmetric. आप किसी भी कार्बन पे आप हाइड्रोजन ऐड कर सकते हो एंड किसी भी कार्बन पे आप your halogen group add कर सकते हो, right? Because it's a symmetric one. So just first step will be, if it is a symmetric alkene and if you are treating it with HCl, right? So just break this bond. Okay, write it down. Break this bond. So it will be, yeah, and add one hydrogen. Add this hydrogen on one carbon. Okay, and add this halogen group on another one. Right. So you will get the product. Okay, so the symmetric one is very, very simple. What you are supposed to do, just break the pi bond and add that hydrogen on the one carbon and the halogen group on the other carbon. You will get the product. And how you can write this one? So it's CH2 and H over here. So it's CH3, CH2, and this is your Cl, right? Basically, this is your chloroethane. Chloroethane. Got it or not? Clear? Yes, Monica and
Yes,
Jupiter,
ma'am.
clear? Yeah, so
Yes.
just remember, if the alkene is symmetric, what you are supposed to do, just break the pi bond and add hydrogen on one carbon and your halogen group on other carbon, right? Similarly, we'll got the product. The main problem is with this unsymmetric type of alkene. That is very important. Yeah. So again, there are two cases. For example, so if the unsymmetric alkene is there, let's suppose, example, I just take it as if CH3, CH, double bond, CH2. Okay, and if you are treating it with halogen acid, suppose it's HBr. Okay, now there are two conditions. If the symmetric or unsymmetric alkene is there, and if you are treating it with halogen acids, now there are two conditions, two cases over here. We will see. First case, when the peroxide is absent, means H2O2. Peroxide is H2O2 hydrogen peroxide. So if the peroxide is absent, and the second case is if the peroxide is present. In both the cases, you will got the different product. Okay. So when you have unsymmetric alkene and if you are treating it with any halogen acids, if the peroxide is absent, then you will use Marconic of addition rule. You know what is Marconic of addition rule? Who will tell me? Who is going to tell me what is Marconic of rule? Marconic of addition rule? Yes, Jupiter.
The,
I think Jupiter, your mic is not working. Niche. Yes, Moniba, tell me.
the hydrogen bonds to the less hydrogen with the carbon, where there's a double bond.
Okay. So basically, the hydrogen attack itself to the carbon, which is having greater number of hydrogen substituents, right? So what is Marconic of addition rule? So just remember that if the unsymmetric alkene is there, so it follows Marconic of rule. And Marconic of rule is what? The hydrogen, this H hydrogen, which is from the, or you can say that the acid hydrogen, right? So this acid hydrogen, it attaches itself to the carbon, which is having greater number of hydrogen substituent, right? So you have to decide it from here, right? This is the unsymmetric one, carbon CH double bond CH2. आपको double bond में देखना है, right? So now see in these two, which carbon has more hydrogen substituents? Obviously this one, right? So this is CH2 here and this is CH. Only one hydrogen is there and this is two hydrogen, right? And according to Marconic of addition rule, the acid hydrogen, it attaches itself to the carbon which is having greater number of hydrogen substituent. And the halogen group, it attaches itself to the carbon atom less, which has less hydrogen substituent, you can say. Right. So what will be the product? Yeah. So just this hydrogen, it will attach to this carbon. Why? Because the hydrogen here is greater, right? So this the product will be SCH3, CH, right? This is CH3, right? Because this was CH2 and one hydrogen attaches itself here. So it will become CH3. Now this is another carbon, right? So here the bromine will be attached. Bromine will be attached to that carbon which has less hydrogen substituent, which has less substituent. So that will be your product, right? So when the peroxide is absent, just always remember when the peroxide is absent, just follow the Markovnikov addition rule. Markovnikov rule. Okay. So you will get what is the name of this product? Yes. Tell me.
2-bromopropane.
Yeah, 2 propane. Clear this one? Markovnikov addition rule clear? When the peroxide is absent, you are supposed to follow the Markovnikov addition rule. Okay, means the hydrogen, this acidic hydrogen, it will attach to that carbon which has a more hydrogen substituent, which has more substituent, and the bromine will attach to other carbon group, carbon solution. Now the peroxide, if the peroxide H2O2 is present, okay, so here you are supposed to follow the anti-Markovnikov addition. Okay, anti-Markovnikov addition rule means this hydrogen, it will attach itself to the less substituted carbon, right? So you will get CH3, right? So here the hydrogen will attach, so it will give you CH2, right? And here the bromine will be attached. The halogen group, it will attach itself to the carbon which has more substituted hydrogen, which has more substituent, right? तो वहां पे जाके bromine will be attached, CH2 and Br, right? So you can see over here in both the cases you will get the different products. So this is your one bromo, it's propane. Okay, so just remember these. Yeah, so this is a case when there is a unsymmetric alkene and when it is reacting with any halogen acid. Okay, so just remember, अगर मैं peroxide absent कर दूं तो just use this Markovnikov addition rule, and if the peroxide is present, then use the anti-Markovnikov. Yeah, clear?
Yes.
Okay, write it down. Let's do some question. Let's see you got my point or not. And yeah, just remember in these two, फॉर एग्जाम्पल इन फर्स्ट पेरोक्साइड व्हेन द पेरोक्साइड इज एब्सेंट तो यहाँ पे 2 ब्रोमोप्रोपेन तो बनता ही है, बट आपका 1 ब्रोमोप्रोपेन भी बनता है, बट इट इज अ माइनर प्रोडक्ट. द मेजर प्रोडक्ट इज योर 2 ब्रोमोप्रोपेन. Okay, similarly in the when the peroxide is present, then the your major product is your when the anti-Markovnikov rule product, right? But somehow there are very less yield of your 2 bromopropane also, right? And that is your minor product. Okay, तो दोनों ही product बनते हैं, but your major product is this. Okay, and the minor product is your 2-bromopropane, right? In the second case, when the peroxide is present. Similarly, in the first case, when the peroxide is present, the major product is 2-bromopropane, but the minor product will be your 1-bromopropane. दोनों ही product बनते हैं, but the yield is very very less. Suppose अगर ये 60% बन रहा है तो वो 40%, just like that. Okay, once written, please inform me. Then we will discuss some question based on this. And yeah, for the symmetric one, you can see the mechanism also. How this reaction proceed, you can understand the mechanism also. So if suppose it's ethene, right? So can we write ethene as the CH, right? This is CH2, right? So we can write CH over here and the hydrogen, I have mentioned it like this. CH2, right? So this HCl, it will break as H plus and Cl minus, right? Because chlorine is more electronegative, right? And this reaction, this step is very slow. This is a slow reaction, right? So this hydrogen, this will abstract this hydrogen from here, right? And it will give you, this will give you a carbocation, right? Here you will see the plus charge over here, right? And now this chlorine, because we know that this carbocation is very, very reactive. So this chlorine, because it is negatively charged, so it will attack this carbocation, this carbon center, and we will get a desired product, which is CH3, CH2, and Cl. Okay, so that's the mechanism of this reaction. Okay.
Yes, ma'am.
Okay, let's do some question. Okay, I'm giving you some questions. Just do that. Okay, question number one. You just have to write down the product. Okay, write down the product for this. Second one, if I give you this side with the structure, here the double bond is this, and here's the substitution phase 3 group. Again, see HCl. Okay, now do these questions. Okay, so just remember the concept which I have taught you. Okay, if there is a absent, peroxide is absent, just use the Markovnikov addition rule. And if there is a peroxide given there, right, along with the reagent, then use the anti-Markovnikov rule. Done? Yeah, good, Jibita. That was for the first one, right? When the peroxide is absent, right? So the bromine will attach to that carbon which has less number of hydrogen group. Yeah. Yeah. So what was the, you have to see these between these two, right? So what was the answer? Right. So this is your CH. So this hydrogen, it will goes to that carbon which has less number, which has more number of hydrogen atom, right? So more number of substituent according to the Markovnikov rule. So it will be CH3. And here the as it is substitution, and here the chlorine group will be attached, right? So this is your final answer. 2-chloro, 2-methyl, and it's propane. For the second one, yeah, tell me, Maniba, what will be the answer? Yeah, Maniba, have you done this?
Oh, yes, ma'am.
Tell me.
Um,
Just tell me where the chlorine will be attached. Here, here, or here?
the first one.
Yeah, yeah. So basically, the chlorine will attach to that carbon which has less hydrogen, right? Which has less substitution. So this is a carbon which has less substitution. So I will write chlorine here, and this is the substitution. So as it is, this methyl group as it is. And on the other end, on the other terminal of the double bond, I will attach hydrogen. Okay, so this is a hydrogen. Okay, so that's your answer, or you can also write it as that's the final answer. Next one, that's again important. When the peroxide is present, right? When the H2O2 hydrogen peroxide is present, then what will be the product?
Br joins the last part.
Yes. Yeah. So the bromine will attach to here, right? So you will get 1, 2, 3. Here the bromine group will be attached. Okay, so that's your final answer. Next one. So you have to decide between this and this carbon. If I write one and two position, right? So just tell me this bromine will be attached to which position, first or second position?
First,
Okay. Are you sure it is first?
yes.
Is the see here the peroxide is absent. Huh?
Yeah, so it goes where hydrogens are less. So
Yes, Jupita, what about you? Tell me the final answer. Just a second. Yes, Yobita, you can write in the chat, bache. Okay, suppose if peroxide is present, then what will be your answer? The different product, right? If the peroxide is absent, then you will use the anti-Markovnikov rule, right? So this bromine will, just tell me on what position you will attach this bromine. Yes, if the peroxide is present, then what will be the product? Yes, Muniba?
It attaches to the second, the two.
Yeah. So this will be your. Now next one, fifth one. Do the fifth one. And then one more thing, just tell me this. If here is a double bond, carbon and here CH2 group, right? And if I use HBr in the absence of peroxide, then what will be the product? Yeah, you just have to see this two. Yeah, this double bond, right? So here you can see 1, 2, 3, 4, right? Less substitution, and here the more substitution is there, right? So this bromine will attach to which carbon according to the Markovnikov addition rule, where the hydrogen is less or greater. Yes, who will tell me?
Less.
Yeah, so just attach this hydrogen and you will get the answer.
For the first one attaches to the last carbon.
Yeah, so according to that, this will be, just a second.
Not the right one. The fifth one.
And you will again got the different product. This product will be, yeah, just remember in both of these, when the peroxide is present and when the peroxide is absent, there will be two products. Okay, anti-Markovnikov product भी कुछ बनेगा when you use a Markovnikov addition rule when the peroxide is absent, but that product will be your minor product, not the major one. Okay, so just remember that if you are writing both the products, so just mention it over that this is your major and that is your minor. Got it? Yeah. So accordingly, just do that. I will give you some homework based on this also. And yeah, again for this one also, this is you can see over here. This is right, this carbon-carbon double bond, right? So here the peroxide is absent. So this bromine will attach to that carbon which has greater number of hydrogen, right? So this will be your final product. This, yeah. So CH2, and this is your bromine over here. Okay, so it is clear now. When the unsymmetric, if I give you some unsymmetric alkene, and when I give you the reagent like your halo acids.
Ma'am,
Now, yes,
for the last one, it joins the other carbon, right?
just a second, which one? Yes,
It joins the other carbon, right?
just a second. Here the peroxide is absent, right? So this is your carbon-carbon double bond. Okay, so according to Markovnikov addition, this hydrogen, it will goes to that carbon which is a greater number of hydrogen. Yeah, so it will goes here, And now, yeah, this is the case where the peroxide is present. Sorry. Yeah, so I have written over here, this is a peroxide case because you know how to use when the peroxide is absent, right? So this was the case when the peroxide is present. मैं यहाँ पे भूल गई थी peroxide. Okay, so, but according to you, that is correct, right? Because you are using the Markovnikov addition rule, so according to you, that is correct. But this is the peroxide case. When you are using peroxide, so that will be the product. Okay, the product is same, but here the case which when we use a peroxide. Got it? Yeah.
Yes, ma'am.
If I just write down without peroxide, so that your answer is correct. Okay, so you have done it correctly. Now, is it clear now? Peroxide and oxide case,
Yes,
absent of
ma'am.
peroxide and the present of peroxide. So just remember, just use the Markovnikov addition rule in the absent of peroxide and just use anti-Markovnikov rule in the present of peroxide. Okay, next method of preparation. We have done this. Yeah. The next is your halogenation of alkenes. Halogenation of alkenes. So basically, when you take alkene, okay, and when you treat it with your halogen group X2, suppose X2 will be your bromine, either bromine, Br2, Cl2, etc. So in that case, you will get vicinal type of dihalide. Okay, vicinal type of dihalide means there are X2, right? Two halogen group is there. X2, right? This is two halogen group. Okay, so what will happen? This when you treat this alkene with any halogen group, dihalogen group. Okay, so you will get vicinal. One vicinal means let's discuss what is vicinal. So vicinal means when the halogen group or any group when it is attached to adjacent carbon atom. Neighbor. Okay, when their halogen group are neighbors to each other, when they are attached to adjacent carbon atom, they are known as vicinal. Vicinal type of halide or vicinal type of group. Okay, any group it could be. But here the halide हम use करें तो we will use vicinal dihalide. Now geminal. Now another word is there which name is geminal. Now geminal is used for that substituent when that substituent is attached or when the substituent is on the same carbon atom. Suppose if it is this carbon, yeah. So if the two halogen group is attached to the same carbon atom, then I will call it as a geminal dihalide. I will call it as a geminal dihalide. And if the halogen group is attached to the adjacent carbon group, then I just call it as a vicinal type of dihalide. Got it? Ramoniba, got it? What is
Yes, ma'am.
geminal and what is vicinal? Is it clear? Right. So when the alkene, when it directly treats it with any halogen group, dihalogen group, so basically you will get vicinal type of dihalide. One halogen group, it just attached to one carbon and the another, it just attached to another carbon group and you will get the vicinal type of dihalide in every case. Okay, so that's the halogenation of alkene. For example, so this is your, yeah, when you react this with Br2, you will get vicinal dibromide, vicinal type of dibromide. Okay, you can also call it as 1,1-dibromo, here ethane. Okay, so similarly, you can write down the IUPAC name also. And yeah, just one more importance of this reaction is method of preparation is basically the bromination. Bromination is used as a test of unsaturation. Okay, so basically the bromination is used as a test of unsaturation, whether your compound is unsaturated or not, whether your compound is unsaturated or saturated. Okay, तो bromination किया जाता है उसके लिए. Suppose if your compound is unknown, suppose you don't know whether it is unsaturated one or saturated one. And you know very well what is saturated and what is unsaturated. Saturation is your alkene, right? Singly bonded carbon, and unsaturated your double bond or triple bond. Okay, so that is your unsaturated hydrocarbon. So bromination is basically used to test the unsaturation. Okay, so for example, if your compound is any you're unsaturated and you don't know if it is unsaturated or not. Okay, so a simple test you can do, just add the bromine water to it. Okay, because we know that bromine water का color क्या होता है? Bromine has basically brownish red color, right? So bromine has brownish red color. So when you add the unsaturated compound to bromine water solution or bromine liquid, so that basically this bromine, this you will get a colorless compound. Okay, तो when कोई भी unsaturated compound जब आप add करते हो bromine में, तो this basically decolorizes your bromine. Okay, and you will get a colorless type of compound. So basically, this test is basically used to test the unsaturation. Okay, so it is very important to just write up. Okay, so what does alkene do? So alkene decolorizes bromine water. Okay, so just remember the you can say this is the application of this reaction. Okay, so basically, alkene decolorizes your bromine water, and this test is basically for used for the unsaturation type. Okay, so basically, when bromine water, right? So when bromine water is added to any alkene, what happens? The bromine molecules, the bromine molecules, because you can see over here, there are two molecules, Br2, right? So two atoms of bromine. Okay, so you can say that when the bromine water is added to the alkene, right, what happens? The bromine molecules add across the double bond, right? So these double bond, these bromine, this break this pi bond, right? This pi bond, and they form two new single bond with bromine atom. Okay, so this bond will break down as you can see over here, and the carbon it makes bond with bromine. They just make a new single bond with bromine atom. Okay, and you can see this process, it basically consumes the bromine. Okay, so that's why this brownish red color, it decolorizes or you can say it disappears. Okay, this brownish color, it disappears, and you will get a colorless compound over here, right? So that's the test which is used for the unsaturation. And yeah, just remember the alkane, because this is the test for the unsaturation. So only unsaturated compound will react with bromine water to give a colorless compound. Alkane, because we know that alkane is a saturated hydrocarbon, so it do not react with bromine water, right? So this doesn't decolorizes your bromine water solution. So that's why we can basically you can say that this bromination, this test is usually performed to distinguish between saturated and unsaturated hydrocarbon. Okay, so an unsaturated hydrocarbon gives this test, gives the positive bromination test, but your saturated hydrocarbon like your alkene doesn't give this test. It gives a negative test. Yeah, Muniba, clear?
Yes, ma'am.
Okay, so have you written this?
1 minute, ma'am. Please fill up.
Yeah, just write it down.
Ma'am, can you explain the Gemini again?
Yeah, geminal dihalide means uh, the halide group which is attached to the same carbon atom. When the halide group or any other substituent, when it is attached to the same carbon atom, then it is known as geminal dihalide, you can say. For example, this is your vicinal dihalide, right? Means you can see over here, this the substituent, this means X. Halogen group is attached to the neighboring carbon atom. Adjacent carbon atom means agal bagal, right? So the carbon atoms, the halogen groups is attached to the adjacent carbon atom. But in the geminal dihalide, for example, same halogen group is there, right? So when it is geminal compound or product, so the halogen group, it will attach to the same carbon atom, right? It will attach to the same carbon atom. So it is known as geminal dihalide. Okay, both the halide group is attached to the same carbon atom. That's why it is known as geminal dihalide. Or it is halide, but we can use geminal word for other substituent also. If the geminal hydroxyl group, if any other group, for any other group, we can use the geminal word. Geminal word basically used for the substituent which is present or attached to the same carbon atom, which is present at the same carbon atom, then we use the word geminal. And if the substituent are attached to the adjacent carbon atom, neighboring carbon atom, okay, then we can call it as a vicinal. Yeah, clear?
Yes, ma'am. Yes.
Okay. Okay, let's do these questions. Yeah, so this is based on, you can see over here, this is the halogenation of alkene. Alkene is there and halogen group is there. You are treating the alkene with halogen group. Okay, so just write down the product. It's very simple. You just have to see this double bond, carbon-carbon double bond, and you just have to make the vicinal dihalide. Okay, there is two bromine group, Br and Br. One bromine group attached to this carbon and one another is attached to this carbon. Okay, and just break this double bond. Okay, first step, just break this double bond. Okay, and attach one halogen group to one carbon and the other halogen group to other carbon, and you will get the vicinal type of your compound. Okay, so for the first one, what will be the product? So it will be 1, 2, 3. Right, so you can see 1, 2, 3 carbon is there. Sometimes the students क्या करते हैं यहीं पे bromine group attached है. That's wrong. You can see there are 3 carbon group, 1, 2, 3. Right. If you are adding bromine group here, then you are reducing the carbon chain. Okay, so you can see there are 2 carbons only. But in the reactant part, there is only 3 carbon. Okay, it's prop. So don't do this like this. Okay, just you are supposed to do this, like attach the bromine atom here. Right, so one bromine here and one bromine here. So that's the product. That's the vicinal type of dihalide. And you can write down the name according to the IUPAC also. Okay, do the second, third, and fourth.
Then,
Then, okay, tell me.
yeah, one fully attaches the
Yeah, one chlorine group here and one chlorine group here. Okay, the second one. It's very simple. Just remember the reagent and what you are supposed to do in the product. Just remember the mechanism. आप अगर mechanism पता होगा तो you can easily write down the product. Right. So 1, 2, 3 carbons. So here one bromine group and here one bromine. Yeah. Next one. Yeah. So this is first position, second position. So on both the position, just attach this bromine. Yeah. So that's the final answer. Got it?
Yes, ma'am.
Okay. Let's do another preparation. Preparative method. Okay. Let's see the another method of preparation, which is by halogen exchange method. Okay. That's very important and very interesting. Okay, so halogen exchange method. So as the name suggests, here the exchange of halogen is there. Right? यहाँ पे क्या हो रहा है? Halogen का exchange हो रहा है. Okay, so in the halogen exchange method, there are three methods. First one is your Finkelstein reaction. Second one is your Swartz reaction, and third one is your Hunsdiker-Borodin Hunsdiker reaction. Okay, so there are three reactions. Just remember that, and each and every reaction is for a specific alkyl halide. Okay, each and every reaction is for the preparation of a specific or particular alkyl halide. Okay, so first one, alkyl iodide. Okay, so I'll basically Finkelstein reaction में क्या होता है? Alkyl halide, alkyl iodide we can prepare. Okay, in the Finkelstein type of reaction, basically alkyl iodides are prepared by the reaction between your alkyl chloride or bromide. We just use either alkyl chloride or either bromide, okay, with sodium iodide, in dry acetone. Okay, so what are the conditions of this? So basically, the reagents we use as the alkyl chloride or either alkyl bromide. Okay, I will discuss why we don't take your alkyl fluoride or iodide. Okay, because fluoride के case में क्या होता है? It's quite electronegative, right? And it's quite you can say sometimes it is we can prepare it using your fluorine also, but in some rare conditions. Okay, and iodide के case में क्या होता है? Because alkyl iodide basically they are very slow reaction. The reaction type जो होता है ना वो बहुत ही rate of reaction काफी slow होता है. That's why we don't prefer to take your alkyl fluoride and your iodide in that case. Okay, so Finkelstein reaction is basically preparation of alkyl iodide. Okay, iodide के लिए ही है. तो हम क्या use करते हैं? Alkyl fluoride or either bromide with sodium iodide. Okay, and in the dry acetone condition, we just use a solvent acetone over here, right? So this is basically, you can see if you use Rx, okay, Rx could be your chlorine or bromine. You can take chlorine or either bromine, and when you treat it with sodium iodide in the acetone, the solvent is your acetone. Okay, so you will get Ri plus NaX. Ri plus NaX. Got it?
Yes, ma'am.
Okay. So basically, we just take acetone. Now, if I ask you why we take acetone as a solvent, what is the role of acetone? So you should know. So basically, acetone it makes the reaction forward favorable, right? तो ये forward favorable बनाता है by precipitating this NX, so that reaction could not be backward, right? Reversible ना हो. That's why we just use acetone over here, right? Acetone का role क्या है यहाँ पे? तो it makes the reaction forward favorable by precipitating this NX, right? So this basically यहाँ से क्या होता है? Na plus X, it just removed it out, and this R, and you will get Ri, okay, alkyl iodide. So basically, just remember, Finkelstein reaction is for the preparation of alkyl iodides. Got it?
Yes.
You can remember this reaction by using your reagents. Okay, sodium iodide we just take and acetone. So sodium iodide and acetone के presence में क्या होता है? So it's a Finkelstein type of reaction, and here you will get your alkyl iodide. Okay, so you can see this is Na, right? Sodium, so NaBr, it will be liberate out. Okay, so it's a, basically, this is a halogen exchange method, right? So here this bromine is exchanged from this iodine, and you will get this product. This is your iodine over here, and plus this acetone, it will precipitate NaBr from this reaction. Okay, and this will be your final product, CH3, CH2I. Got it?
Yes.
Okay. So this one, next one.
In place of Cl, argon, and plus magnesium.
Yeah, just exchange this chlorine from iodine, and you will get sodium chloride. Sodium chloride will be precipitate out. So that's the Finkelstein type of reaction. This is the halogen exchange method. Okay, it's just remember you are just supposed to do the exchange the halogen group. Okay, and you will get the product in the Finkelstein type of reaction. Just remember you will get alkyl iodide. So easily you can write on the product. Okay, now write on this.
Done.
Okay. Okay, next reaction is Swartz reaction. Okay, this is again a halogen exchange method. And now just remember this method is used to prepare fluoride, alkyl fluoride, or you can say fluoroalkanes. Okay, so see, first halogen method was Finkelstein method, and that was for the preparation of iodides, alkyl iodides or iodoalkane. But the second, this is Sword method, Swartz reaction, and the Swartz reaction is for the preparation of fluoride one. Okay. Now see here, when the chloro or bromoalkane, so here we will take the chloro or bromoalkane when it is treated with metal fluoride. Okay, here we just take metal fluoride. So this metal fluoride, when you treat this your alkyl chloroalkane or bromoalkane with metal fluoride, you will get your corresponding fluoroalkane or alkyl fluoride, you can say. Okay. For example, and basically in this type, we just take, for example, your AgF, silver fluoride, mercuric fluoride, etc. Okay, so basically we metal fluorides like AgF or Hg2F2 we just take as a metal fluoride. Okay, for example, let's take CH3Br, okay, bromoethane, bromomethane, sorry. So when you treat it with metal fluoride, suppose it's AgF, silver fluoride. So what will be the product? So this bromine, it will be exchanged by this halogen fluorine. Okay. So CH3F, you will get fluoromethane plus this AgF. Okay, you will get AgF as a byproduct. Okay, so that's the SWOT reaction. The SWOT reaction is basically for the manufacture or for the production of fluoroalkanes. Got it?
Yes, ma'am.
Next one. First understand this, then I will give you time to write down this. Third one is your Huns-Dekker reaction. Okay, इसे हम बोरोडिन Huns-Dekker reaction ही बोलते हैं. So Huns-Dekker reaction is basically for the formation or production of bromoalkane, right? So it is for the bromoalkanes. So basically bromoalkanes are prepared by refluxing silver salt of acids with bromine in carbon tetrachloride. ओके सो बेसिकली कैसे हम इसे प्रिपेयर करते हैं हम इसे रिफ्लक्स करवाते हैं एंड नाउ आई विल टेल यू व्हाट इज रिफ्लक्स सो रिफ्लक्स एक टेक्निक होता है इट इज अ टेक्निक और यू कैन से प्रोसेस which involves the evaporation and condensation in which the evaporation and condensation takes place simultaneously राइट साथ साथ आपका सिमिलर इवापोरेशन होता है एंड साइकिल चलता है राइट तो वहां पे साइकिल चलता है लाइक एवापोरेशन हुआ नीचे से देन वो वेपर्स ऊपर गए देन मिररली वो कंडेंसेट हो गया एंड दिस साइकिल गोज ऑन दैट इज अ रिफ्लक्स प्रोसेस दैट टेक्निक इज basically used to obtain your product. Okay, and this happens because we know that evaporation it happens at a very high temperature, right? So this process basically uh, it happens around 350 to 380 Kelvin. Okay, so basically reflux क्या होता है तो it technique or process that takes place in which the evaporation and condensation takes place simultaneously. Okay, so in this process, in this preparation, the we just do the reflux, okay, and we just use the silver salt of acid, okay, silver salt of acid, silver acid salts we can say, with bromine in carbon tetrachloride. For example, the reaction, the general reaction is RCOOAg, right? So you can see this is the silver salt of acid, right? Plus Br2 in the presence of CCl4 carbon tetrachloride, and when you do reflux, you just got RBr. You just got bromoalkane. Okay, so just let's understand what are these. So basically, you can see over here the mechanism of the reaction. Um, Here, the reaction, this silver salt of carboxylic acid we just used. This is the silver salt of carboxylic acid. Okay, RCOOHG, right? So obviously, this silver, it will get positive charge and this CO, it will get negative charge over here, right? So what happens is basically a substitution type of reaction, right? So यहाँ पे क्या आता है? It is basically a substitution type of reaction. So here, the halogen group, this halogen group, it replaces this carbonyl group, carboxyl group, right? This COO group, this halogen, it basically, it replaces this carboxyl group, right? And the reaction it is characterized by decarboxylation. यहाँ से क्या होता है? Decarboxylation. This COO group, it just removed, okay, from this, right? So from here, this CO2 will be removed. It just removed as a CO2 plus your Ag. This is your Br2, right? Br and Br, right? So this one Ag plus it goes with one Br, right? And this CO, this CO2, this carboxylic acid group, it just removed as a CO2, right? It just liberate out. And this AgBr, it will be as a byproduct, it just formed, and you will get RBr over here. the main product we will get as a bromoalkene. Basically, just remember, suppose, yeah, so basically you just have to remove this COO, right? C double CO2, तो आपको remove करा देना है, right? And just this Ag, it will goes with one halogen group, one bromine group, and one bromine group. It is attached to this alkyl group to give you corresponding bromoalkene. Okay? Is there need to explain it again, Muniba?
No, ma'am.
Clear?
Yes, ma'am.
Suppose this CH3CO minus Ag plus. Okay, so we know that metal पे क्या होता है positive charge, right? So corresponding oxygen will get negative charge over here, right? So again, same mechanism, just remove this, right? So this CO minus, it will remove as a carbon dioxide gas, and this Ag, right? Because we know that this bromine, right? So being a electronegative element, it has a negative charge. So this Ag, it will goes with this, right? So AgBr, it will form AgBr, and this CH3, because CH3 is alkyl group, it is some electropositive type, right? So this bromine will attach again over here. So it will give you CH3Br. So that's your final answer. So you just have to remember these three halogen exchange method. First one, Finkelstein. Right, Finkelstein reaction is basically for the production of iodo, yeah, iodo group. Then second one, Swartz reaction is for fluoroalkane. Then the third one, Hunziker, is for bromoalkane. Yeah, got it? And just remember the your reagent, corresponding reagent. Okay, now you can write. Scroll down.
Yeah. The last one.